bottom of a wine glass or a stemmed glass. It's kind of neat to look at. But yeah, because this would actually bend the light around the black hole in a way. Doesn't that look cool?
It looks kind of like it was a bullet hole on a car or something.
Yeah. All right, so, now this slide is almost probably unnecessary, but just as an example, I want to start talking to you guys between now and the end of the semester about how light behaves, because light is really what you're dealing with all these challenges with tonal renderings, with surfaces, with textures, with optics. You're really talking about light. And it's really important, I think, that you start getting a physical understanding of what we mean when we say light. We don't just mean turning on a light bulb. We're talking about energy. And this is why I think it's important, because what you were just asking about, well, what ratios do I use for this? This is where I think this will help as much as anything can, is you need to be thinking in terms of how much energy is hitting this. Well, it's getting energy from here, and it's getting energy from here, and it's getting energy reflected from here and here. You see what I mean? And it starts adding up. Now, if you have that little tiny shadow in the middle that's not receiving any, that's because no direct energy is hitting it. But some energy is. And that's why we see it as a tone at all. And it's not like a black hole where it's an absence. You see what I mean? And that's also why shadows are not black. If shadows were black, it would mean no light was coming from there. And that's almost unheard of. It happens at certain times, but it's not very common. Certainly not at our scale. So anyway, so all of these things, I was almost going to do a lecture on, I did a lecture on the optics of air and atmospheres. I did a lecture on the optics of water, and I thought, oh, I should do 2 more lectures. I could do earth and fire and have like the 4 elements. There was a nice symmetry there. And I started to make notes for a fire lecture, and I realized it kind of doesn't work. And the reason it didn't work was because when you're doing air and water, what you're really lecturing about is how light behaves in air and water, which you can really talk about. When you talk about fire, what you're really talking about is combustion. You're talking about energy. So now you're not talking about how to illustrate light in a medium. You're talking about how to illustrate light, which is impossible. Because you're dealing with subtractive mediums. It doesn't work. You see what I mean? So anyways, that's more than we need to talk about, but you get the idea. This is a physical understanding of light. Now, so what is a reflection? What we call a reflection is this. It's the very efficient reflection of light. That's what we really mean when we say reflection. Now, I'll show you what I mean. 2 black cars. One is a very efficient reflector, and one is not. Yeah. This one?
Yeah.
Bless you. You good? Yeah, so what that means is, like in this next slide, the shiny black car is smooth and it's polished at a microscopic level. To the point where if a light ray comes in here, one light ray, or effectively, not quite correctly, but if light rays come in here, they bounce at a particular angle and they stay together kind of. They bounce at about the same angle. So you get, and when you have a really efficient reflection, what you end up with is you end up with a picture of the environment. Okay? When you have something like this, this is still reflecting light, or you wouldn't see it. Okay? But what's happening is you're seeing the reflection inefficiently. Let me give you an example. You guys, where are these palm trees? They're up here. Okay? The light comes in and bounces that. We're seeing it like a mirror. It bounces right off the hood. Okay? But look at this one. we are seeing a reflection here. That's the sky. Do you see that this color is added to the black from this color? When you're painting this windshield, you're not painting, oh look, we can even see clouds in here. You know? Okay. So when you're seeing all this stuff, you're seeing the reflections of the sky. You're just seeing them imprecisely. You guys, an interesting thing about this, about reflections, was when I was doing the Optics of Water lecture, which I hope to be able to give you later in the semester, because it's kind of a fun lecture and it sort of relates to what you're going to be doing, is one of the key points that I made in the water lecture is that as a painter, one of the things you need to remember is when you think you're painting water, you're usually not. Water's a medium. It's like when you think you're painting air. You're usually not painting air. What you're painting is you're painting crap that's in the air. You see what I mean? If you were painting air, there would be nothing. Same thing with water. Water is conducting conducting medium for the light. If you're painting it, you're usually painting a reflection of the sky or a reflection of the bottom of the underneath the water, or you're painting something else. You're almost never painting the water. Okay? Now, here's another example, and Brandon almost gave this away. You guys, look at the front of the matte car. Look at this car. Look out here. What color is the car in front of it?
Red.
It's red. It's obvious, you know? So it's reflecting. It's just reflecting inefficiently. Yeah, Brandon. It was okay. So now let's go forward a little bit from here. Oh, you guys, one last thing I forgot to mention about this. Wait, hang on, I want to see something here. Okay, I thought I might have some notes that I wasn't reading to you guys. You know, I put this in here and I kind of went, what the hell was I talking about? Oh, yeah, okay. Here's something I want you to notice also about the difference between shiny things and matte things. Imagine you've got a full value range. Okay? With this, you get an accurate reflection. So if something comes in and it's white, it comes off as white. If something comes in and it's black, it comes off as black. If energy is coming in and it's creating a gray value, it comes off as a gray value. You see what I mean? It comes off fairly cleanly translated. But with this, what's happening, you know, like in the note here I have, imagine a 10-number range. You know, you pick 10 numbers and you do it randomly, so it's 2, 7, 8, 5, 6, 1, you know, whatever. This you would get 2, 5, 8, 7, 6, 1. This you get an average. Do you see that because of that, the value range of this is going to compress both in the lights and in the darks? Everything's going to go towards a middle tone because the whites are not going to come off as white and the darks are not going to come off as dark because they're going to be averaged by the way it scatters. Does that make sense? So that's why when you have glossy objects, you have higher contrast ranges. Okay. All right, so let's play around with this a little bit more. And again, going back a little bit to what you were talking about how dark to make them and how to think about it. Look at where the darkest areas are. The only really dark areas you have, and they're dramatically dark, are the occlusion shadows. You know, everything else is, you know, except for this little shadow here, neither light is hitting it. But everywhere else, you're getting a fair amount of light, even in the shadow, except for this little light trap right in here, which is a kind of occlusion shadow, and then this stuff here, which isn't getting light from either side. Okay, now let's mess with them some more. Oh, one thing you guys, that I need to point out, this is an unfortunate photographic artifact. Remember how I was telling you last time that your eyes are not cameras, and that cameras have a hard time detecting some of the stuff we're seeing? If you set this up, you would see it differently than you're seeing it here, and let me give you an example of why. Look at this value here, and then look at it, the original. That's blowing out because of the way the highlight is overpowering the camera. The camera was kind of exposing for one thing, and the way the angles were, it was bouncing a light right into us. And it just, the camera couldn't handle it. So it started, see how there's no, if you went into this and looked at it at a pixel level, there's really no information in here because it's getting outside the dynamic range of the camera chip. Okay? That's not, you would see it more like this if it were not happening. So again, just notice the only place where you have the really dark shadows are where you're not getting light from either side. And even in here on what is ostensibly the shadow side of the cube, because this whole side is in shadow, but there's so much more light in the environment it doesn't feel that dark. Because there's light bouncing everywhere. Now this is, when we were setting these up, you guys, one of the reasons I'm so happy to see you guys become kind of nerdy perspective people is when Angela and I were, and I think Angela and I, were you guys helping us shoot these last semester? We were nerding out about these, like, oh, check that out, oh, check that out, oh, take a picture of that, and like, oh. And this is one of the things that we looked at it, and for a second, someone brought it up, it's like, what the hell's causing that? Where's that coming from? And we were trying to figure out why, and I can show you why now. I drew, once we figured it out, I went, oh, okay, and then I drew a diagram because I thought I want to explain that to the class. Well, have you guys ever been to a restaurant where, well, I'm sure you have, where you order and they push the food, or like they place the order through like a little window with the person, and they hand the food back, like the kitchen's behind the little window and they just have a little opening? That's basically what's happening. Because the mirror plane stops here, this ceases to function like a mirror, and you end up getting this. It functions like a window for the second light source. You see what I mean? All right, now, just to show you a few additional weird slides.